Hey guys, welcome back to Code in Action, the series where we build practical backend projects step by step. In this tutorial, we're going to implement a simplified version of the Bitly API, the popular online service that allows you to convert long URLs into shorter and easier ones to share. Our API will include two endpoints, an HTTP post shorten that will store the user-provided URL and respond with a custom link pointing to our server containing a short ID, and an HTTP get short ID that will retrieve the original URL corresponding to the short ID and redirect the client to that URL. By the end of this tutorial, you'll know how to normalize URLs, generate unique IDs, store and retrieve in-memory data, redirect clients, and return appropriate HTTP status codes. Guys, it's no secret, learning backend development on your own is extremely hard. Before becoming a senior Node.js engineer with now over a decade of experience, I've also failed at it for years, and probably for the same reasons that you're struggling with it right now. So this is why I created the Learn Backend Mastery program, a program designed to remove all the guesswork and to take you from dabbler to job-ready Node.js backend developer in only 12 months. The program is centered around an interactive roadmap of 136 lessons spread across 11 branches like the CLI, Bash, JavaScript, Node, SQL, Express, and more, allowing you to always know what to learn, when to learn it, and in which order without confusion. Each lesson is crafted to teach one specific concept in a beginner-friendly and straight-to-the-point way, and is illustrated with code snippets you'll actually use in real projects. And because only practice makes ready, the Mastery program includes 25 hands-on projects with step-by-step commented solutions you can study, including command line tools, system simulators, games with simple AI, online services, and more that will truly challenge you and help you build a bulletproof problem-solving mindset. So if you want to get serious with backend development and make real progress fast, check out the Mastery program at learnbackend.dev/get-started, link in the description below. And without being said, let's build. As always, let's start by creating a new directory for our project named Bitly Lite. Once created, let's enter the project, create the package.json file using the npm init command, and install the Express package for implementing the API and the Nanoid package for generating secure URL-friendly Unix strings ID. Within the root directory, let's create a new file named server.js. Within this file, let's import the Express package, create a new server instance by invoking the top-level function exported by the package, and bind the server to the development port 3000 using the listen method of the server instance. Now, in order to keep this project simple, we'll use a global object literal named URLs as in-memory database to store the user-provided URLs and their matching identifier. Each property of the URLs object will have the following format, where short ID is a unique string identifier for a shortened URL of 6 characters exactly generated using the Nanoid package, and original URL is the original URL string provided by the user. As a side note, keep in mind that this type of in-memory storage is not suitable for production, as the data will be erased every time the server crashes or restarts. Let's now declare a new HTTP post shorten endpoint that will be responsible for parsing and storing a user-provided URL and responding with another URL pointing to our server containing a short identifier. Note that since we expect the message body of incoming HTTP request to be encoded in the JSON format, we'll use the JSON middleware to automatically convert it into a usable JSON object. So first, let's extract the user-provided URL to shorten from the message body of the request, which will be specified under a property named original URL, and respond with an HTTP 400 bed request if it's unspecified or its value is null. Now, at first glance, two URLs may look different and even be written differently, but actually point to the same place. For example, these two URLs are equivalent. With that in mind, normalization allows us to bring consistency to our API by trimming spaces, forcing lowercase domains, stripping unnecessary slashes, and so on, in order to avoid storing two identical URLs as separate entities, therefore wasting IDs and creating duplicates. So let's start by removing white spaces from both ends of the URL using the trim method. Let's then prefix the URL with the string HTTPS if it doesn't start with a scheme. Let's declare a try-catch block, and within it, initialize a new URL object using the built-in URL class and respond with an HTTP 400 bad request if it throws an error during instantiation, which means that the URL format is invalid. Let's now remove any duplicate and trailing slashes from the URL's path name using the replace method. Let's sort the URL's query string parameters in alphabetical order for consistency. Let's remove the port number from the URL if it matches the standard HTTP and HTTPS ports. And finally, let's convert the URL object back into a string using its toString method. Once we've done that, let's import the Nanoid package at the top of the file for generating unique identifiers. Then, in order to avoid unnecessarily storing duplicate URLs, let's implement a simple caching mechanism using a for loop that will iterate on each property of the URL's database object and return using the JSON method of the response object a URL that points back to the second endpoint of our server containing the corresponding short ID if it already exists. Finally, if the URL hasn't been previously stored, let's generate a new unique identifier using the Nanoid package. Use this identifier as key to store the original URL in the URL's object, and return a custom URL that includes the identifier. Let's now test our endpoint by adding a temporary log that outputs the content of the URL's object every time a new URL is added. Let's start the server and test various scenarios using the curl command to send HTTP POST requests to the endpoint. For example, when sending a request with no message body, the endpoint should respond with a 400. Same thing when sending a request with an invalid property or an unspecified URL. On the other hand, when sending a request with an original URL property and a valid URL, the endpoint should respond with an HTTP 200 containing the custom URL, and the server should output the following log. Finally, when sending the same request twice, the endpoint should respond with another HTTP 200 containing the same URL, and the server should not output a new log this time. Let's now declare a new HTTP GET endpoint responsible for retrieving an original URL based on its identifier and redirecting the client to it. Let's extract the short ID property from the query string parameters object and respond with an HTTP 400 bad request if it's not 6 characters long or includes characters that are not letters, digits, underscores, or dashes. Let's then attempt to retrieve the original URL from the URL's object using the short ID variable as key and respond with an HTTP 404 not found if the key doesn't exist. Finally, let's redirect the user to the original URL using the redirect method of the response object. Let's now test our endpoint by first killing the server using Ctrl+C, restarting it, and sending various HTTP GET requests to it using the following curl commands. So let's first store a new valid URL using the following curl command, then send a request with an invalid ID format, which causes the endpoint to respond with an HTTP 400, then send another request with a valid but non-existent ID this time, which causes the endpoint to respond with an HTTP 404, and finally, let's send a request with a valid and existing ID, which causes the endpoint to respond with an HTTP 302, including the original URL. The URL shortener services are usually easy targets for abuse, as attackers often try to hide links to local machines or private networks behind short IDs. We'll add a tiny policy layer that refuses to shorten URLs pointing to these special addresses or ranges, including the local host, the loopback address, private LANs, and link local IPs. So at the top of the file, let's declare a new global constant named Blacklist and initialize it with an array of undesirable hostnames like scam.com or phishing.net. Let's then update the first shorten endpoint one last time to check if the URL's host name is in the Blacklist array or matches any of the IP patterns specified above using various regular expressions, and respond with an HTTP 403 forbidden indicating that the request is valid but not allowed by policy. Let's now test our changes by killing and restarting the server one last time and send various requests containing the URLs and IP addresses previously specified in the blacklisting policy which, as you can see, all cause the shorten endpoint to respond with an HTTP 403. And here it is for today, guys. As always, if this video clicked for you, don't forget to hit the like and subscribe buttons, as it will really help me grow this channel. Also, if you want to play around with the source code of this project, you can download it directly on the Learn Backend website. And don't forget to check out the Mastery program, your roadmap to becoming a job-ready Node.js backend developer in 12 months. Oh, and because I want this investment to be an absolute no-brainer for you, it comes with a 30-day money-back guarantee. This means that if you're not 100% satisfied with your experience within the first 30 days, I'll refund your entire payment in 24 hours. No hard feelings, no questions asked. Thank you for watching and see you in the next one. Cheers.